Okay, and we're live again. So thank you so much for joining us for another session of JNation 2021. We're still going strong. We're like, really past the middle of the conference. So we still have like 4 sessions left. And I'm really happy to introduce to you our next speaker, which is Reza. Hey, Reza, how's it going?
Hey, Roberto, what's up, man?
Yeah,
Looking good.
looking good. So I still remember that the last time we chat was like in the very last conference that it was physical. It was like in Atlanta, like a
I know.
couple. So like
Seems
the
like
memory,
forever now.
it is right, and no one really had any idea what was going on later. But I think we're pretty happy that we were able to meet up at the conference, and at least we still have those fun memories.
Yeah.
Uh,
Hopefully we get back to it soon at some point.
yeah. So if you don't mind, I'm just gonna do like this personal thing. So Reza, I have like a tremendous amount of respect to you because I mean you did so part of those things happening right now is I mean you gave me a lot of strength to like start the Java user group here in Portugal and gave me some counsel. So thank you much for that. So in some sort, I think you should be proud on what we're doing here today in Portugal as well. Unfortunately, we cannot have you physically, but maybe we can have you next year.
No problem, man. It's as you know, like this community is big in some way and very small in another. So we have to support each other, and we have
Yeah,
to try our best to basically make a difference the best we can.
wonderful. So Reza, I know you're going to talk to a very touching subject in the sense that I really love this subject, and you've been working on this for forever, right? So talk us a little bit on the past and the future of Jakarta. So I think it's going to be very interesting, especially we are in this transition period, so there are a lot of questions, a lot of doubts. So I think it's going to be interesting for our audience. So Reza, whenever you want, feel free to go.
Okay, all right, let me share my screen. Do me a favor and just confirm for me that you can see my slides okay. So let me just do a quick setup and then I'll ask you to confirm for me.
Yeah, for
I just
sure.
need to move some things around to make sure it's presentable. Okay, already. And I think that's not going to work. I need to put it over there. Okay. All right. Can you see my slides okay?
Yeah, everything's okay.
All right, perfect. So let's get started. All right, so this talk is, as Roberto mentioned, pretty close, near and dear to my heart. So this is Jakarta EE present and future. So it's a little bit about what is going on in the Jakarta EE ecosystem today. How does it look like? And what does the future bring? And frankly, to be honest, this is the entire talk, at least a good portion of it, is a call to action. So I do hope that you brought your thinking caps on, and the mindset you should have while listening to this talk is how you can contribute, I hope. Not simply just being a consumer, but an active participant in the Jakarta ecosystem. And frankly, this is one of the key reasons why we did what we did with the Java EE to Jakarta EE transition. So if we don't have that, honestly, we would have not succeeded in a fundamental way. So a little bit of a introduction of myself. In my day job, I'm principal program manager for Java on Azure. What that means is I try to make Azure a little bit more of a friendly cloud for Java developers. A lot of that work is actually related to Jakarta EE and Java EE in some way or the other as well. So, at least part of my day job is definitely dedicated to Jakarta EE and Java EE as a technology. But today, actually, I'm not delivering this talk as principal program manager for Java on Azure at Microsoft. I'm delivering this talk as a Jakarta EE ambassador. In fact, my hope is that all of you will take this presentation and make it your own. So that is one of the objectives for me here today, is to train the trainer, if you will. So this presentation is publicly available. Obviously, I'm available to help you. I hope that you will, after doing this talk, you will actually consider presenting this talk in another venue yourself, like a Java user group or a conference, or perhaps even internally at your company. So I'm part of the Jakarta ambassadors, a group that I was proud to say I was able to found a few years ago. I'm also an author, blogger, and a speaker, and I've been in the Java ecosystem, the Jakarta ecosystem, for quite some time now. I think it's about 15 plus years. There's my email and Twitter handle. If you need to get in touch with me, you absolutely can. In fact, if you go onto my website, there's a contact me page there. You can even give me a call if that's what you prefer to do. All right. So without further ado, hopefully all of you already know what Jakarta EE is, but just in case you don't, here's a very brief introduction of what Jakarta EE is. Jakarta EE is the technology formerly known as Java EE. It used to be hosted in the JCP or Java community process for a very long time. The JCP is really nothing much more than a department of Sun and then Oracle. Jakarta EE, on the other hand, has been transitioned fully to an open source foundation. So all of the IP, all the governance, everything is owned by the Eclipse Foundation. It is not, obviously the Eclipse Foundation is a non-profit. So basically everybody owns Jakarta EE, whereas Java EE really fundamentally or effectively was really owned by Sun and then Oracle. So this is a very important step, and it is, in terms of openness, frankly, Jakarta EE is the most open technology in the Java EE space. And it's on all of us to make that a reality. It just doesn't happen on its own. And hopefully I'll be able to convince you that this is something that you should believe in and actually contribute towards making a reality throughout the course of this talk. So what this means is, again, it has open governance. It's completely open source, including the TCK. The TCK is running the TCK is significantly easier than it has been throughout the duration of J2E and Java EE as a technology. It still has a well-defined specification process. Just because it's moved to the Eclipse Foundation doesn't mean we stop being what makes Java EE an open standard or open specification. So there's a well-defined specification process. There's a very clear IP flow. Really, fundamentally, nobody really owns the IP. So what that means is if one person stops developing a technology, another person can pick up. That's why the clear IP flow exists. It is geared towards completely vendor-neutral open collaboration. So it doesn't matter if you are a multi-billion-dollar organization like Microsoft, or you're a one-man shop that has a beta Jakarta implementation. The playing field is level. It's all about what you can do, not who you are. The key stakeholders have remained basically along what it had been in the Java EE days. So Oracle, IBM, Pyara, Pivotal, all of these folks, Red Hat, all these folks are still there. And things are expanding a little bit. In fact, the latest news is SoJava has joined the Jakarta EE membership. And there's a long list of membership that's there. And all of you, actually, you should consider seeing whether you can become a Jakarta EE member yourself. But the key, again, is that community participation and contribution. Right? Without that, we would have not really accomplished very much, other than perhaps making it vendor neutral. And I'll talk a little bit about how we do that contribution precisely. And one simple contribution, again, is just to deliver this talk yourself. So if you want to find out more about Jakarta EE, the best place to begin doing that is jakarta.ee, the website. So let's talk a little bit about the importance of Jakarta EE. And this, honestly, is a fundamental challenge. A lot of people think that, oh, Jakarta EE is not relevant, I'm not using it, so it doesn't matter, so on and so forth. Or even worse, no one's using it. Right? This is very far from reality. Right? When you take a look at the objective data, I think what typically happens is that Jakarta EE developers are somewhat quieter, so they're not as noisy and not as vocal, but they are there. Especially, I can tell you, even in my day job, we are working with these customers on a day-to-day basis that are, in fact, using Jakarta EE implementations. And not only that, they're moving to the cloud, moving to things like Kubernetes, moving to things like platform as a services. It's just that because they're not as vocal and not as noisy, people think they don't exist, but that's very far from the truth. So here's these results, though, maybe don't show up in Twitter sphere or Facebook, but it does show up in the data. Right? So here's some data. This is the 2023 Jakarta EE developer survey. There's going to be an updated version of the survey coming out hopefully in a few weeks. In all reality, when you take a look at the averages, in all reality, still about 25 to 35% of developers wind up using some kind of application server or the other, whether it's WebSphere, WebLogic, JBoss EP, Wildfly, Pyara. Above and beyond that, a very large part of the Java ecosystem, in fact, I'd say almost the entire Java ecosystem, is dependent on some kind of Jakarta EE API or the other. And I'm not just talking about Servlet. Servlet is an obvious example, but it goes far beyond that. So if you look at Tomcat or Hibernate or AMQP or Jetty or Microprofile or Spring or Quarkus, believe it or not, you are a Jakarta EE developer, whether you realize it or not, because you have heavy dependencies on Jakarta EE as a technology. Without Jakarta EE as a technology being there, these technologies all would look very, very different. In fact, the entire ecosystem would look very, very different. We would probably be something like the Balkans. Like everybody would be very similar, but they would behave as though they're very different. Jakarta EE APIs and Jakarta EE as a technology is what unifies us to many extent as cloud and server-side Java developers. So extremely important. And it is an evolving ecosystem. We'll see that in a moment. Jakarta EE itself is evolving, but there's also active evolution, and there has always been active evolution around the ecosystem as well. So you have things like Eclipse Microprofile, you have things like Quarkus, you have things like Helidon. All of these things are part of the evolution story of Jakarta EE. So Jakarta EE, when you think about it, don't think you're just talking about application servers. It's far beyond that, right? Application servers are from the core, but frankly, every Java developer is touched by Jakarta EE in some shape or form or the other. In fact, if I would say, take away one message from my talk today, take away this message. In fact, we are all Jakarta EE developers in one way or the other. All right, so a bit about the Jakarta EE evolution. So Jakarta EE has been around for a very, very long time. In fact, I'm very proud to say I've been around Jakarta EE roughly around the J2E 1.4 timeframe. I was an observer and to some extent a contributor as of Java EE 5. And I've been essentially involved in evolving this technology ever since. So as I said, it's been about 15 years plus or minus for me. I won't go through in the entire evolution, but basically this technology, I don't know how many people knew about this. I at least heard about it. I didn't use it, but it started its life as something called Java Professional Edition, or JTE. Then it was called J2E for some period of time, but a very short period of time, as you can see in this timeline. For some reason, we still call this thing J2E, but it's like just so grossly out of date a term. But then we have evolution to Java EE and POJO-based programming and lighter weight runtimes, in my opinion, perhaps the most lightweight programming model for sure, and it has been for some time. And all the way to the evolution of Java EE 8, the last revision that was released under the JCP. With Jakarta EE 8, you had open source governance, so the entire technology set moved to the Eclipse Foundation. Believe it or not, this is one of the largest technology and IP transfers that has ever happened in the Java ecosystem. In fact, maybe even in the industry. So very, very significant development, and it's really remarkable that that has happened. And now we are in Jakarta EE 9.1 and 9.0. I'll talk about that in a second as to what precisely that means. And we are looking forward to Jakarta EE 10. Hopefully by sometime end of this year or early next year, you'll see Jakarta EE 10. And this is where you need to put your contribution hat on. This is your opportunity to really become an active contributor to an important technology in our ecosystem. And I'll be spending at least a decent amount of my time talking about how you go about contributing to Jakarta EE 10. Jakarta EE 8 at a glance. If you haven't seen it before, you definitely should. We worked very, very hard back in the time of defining Java EE 8. We defined it through a lot of user research and surveys. Because of that, we actually have a very strong foundation, and this is one of the foundational reasons why it has been able to be evolved, even though the transfer process took time, is because Jakarta EE 8 was a solid foundation and a relatively feature-complete technology set, especially for monolithic applications. This is why people can take bits and pieces of Jakarta EE 8 and still make it work, even in a very, very fine-grained microservices environment, be it Quarkus or Microprofile or even Spring Boot. But this is a list of features that were there very quickly. Web standards alignment with HTTP2, addition of service sentiments, which is part of HTML5 body of standards, adding JSON binding and JSON processing as a first-class citizen of the platform, including support for more advanced JSON specifications like JSON pointer and JSON patch. I bet some of you may not have even used that yet. CDI alignment, so aligning the different parts of the platform towards one cohesive programming model, and this is an ongoing work, as you'll see in a moment when I talk about Jakarta EE 10. But we had a good solid release of CDI 2 It has some interesting features like asynchronous observers and Java SE Bootstrap. Again, those are features that have enabled CDI to remain relevant, even though really have not been any active development for about a couple of years now. Simplicity is always a theme for Java EE, going all the way back to Java EE 5. So got some good examples of that is a Jakarta EE Security API, as well as pruning older technologies, and we'll continue to prune. In fact, some technologies have been pruned even in Jakarta EE 9, and we'll continue to prune these technology sets to keep the platform fresh, I hope. Java SE alignment is always an important thing. So various bits and pieces of these technology platform needs to be aligned and take advantage of Java SE features, because Java SE, especially Java SE 8, had some very interesting features in it. So things like repeatable annotations, the datetime API, streams, completable features. So the APIs needed to adapt to make sure that it is consuming all of those innovations in a sensible way. The next one in the horizon probably is Java records. It is similar in appear to these sorts of changes that happened in Java SE 8. But certainly, as a general statement, Java for Jakarta EE 8, we always want to make sure that we're consuming things from the ecosystem. The most important part being Java SE innovations. So we'll talk a little bit about Jakarta EE 9 and 9.1. Basically, the main objective there is not just move away from the code base and the IP, but also the copyrights. Okay, so the last bit of problem that remained after the Jakarta EE 8 transfer was that everything was still in the javax namespace, and the javax namespace, the copyright is ultimately owned by Oracle. So the problem with that is, in order to be able to evolve these technologies, ultimately you still have this copyright tie-in with Oracle. So in order to truly make it an independent specification, we needed to move the namespace away from javax to something called Jakarta. And in fact, this is what was done in Jakarta EE 9. So Jakarta EE 9 and 9.1 is completely decoupled from the javax namespace, and everything is in the Jakarta namespace now. So truly, truly open. There's not even a copyright binding, no API bindings, no IP bindings, and no source code bindings with anything proprietary either. So it's completely open source. There were some older technologies that were removed in the process, things like JAX RPC and the like. But the primarily aim of Jakarta EE 9 and 9.1 is actually for vendors or the ecosystem to catch up, right? Specifically with the transition to this namespace. And most of the ecosystem has. Tomcat has done that. The Spring folks are doing that. Hopefully Microprofile will be doing the same thing. So large parts of the ecosystem are actually on board with this namespace transition, and that was the objective. So I would say so far so good. It's relatively successful in that regard. Now you might ask, what is the difference between 9 and 9.1? The big difference is that 9, because of the reason that it had to be delivered relatively quickly, it still basically had the same Java SE dependency as Jakarta EE 8, namely Java SE 8. Whereas, obviously, that is not the latest LTS anymore, right? So what happens with Jakarta EE 9.1 is that the Jakarta platform embraces a newer LTS, which is Java SE 11. The next LTS, as you know, is going to be Java SE 17. So hopefully, Jakarta EE 10 will actually be embracing that LTS version, because I think it's due in October, something like that. But you should definitely begin testing. If you have Jakarta EE dependencies, as I said, the ecosystem is moving forward. Your applications will also need to move forward. So you should begin testing and experimenting with Jakarta EE 9 and runtimes, including the latest version of Tomcat, and see how your applications behave, see how you do. All right, so I've been talking for a little while. Let me just finish this one slide, and that is a good point to pause, because I've also been speaking for about 20 minutes, and I'm going to just see if you have any questions. So that is another thing that I should mention. Please don't hold questions until the end. There's no reason to do that. The slide deck is available, and wherever I get to, it's going to be enough for you to pick up from there. So definitely don't hesitate to ask questions. Please ask questions throughout the session, and I will answer those questions throughout the session as well. So Jakarta implementations are looking very, very good. If you look at the compatibility page, actually, surprisingly, I have not seen as many Jakarta implementations that are there now, probably since the J2E, early J2E days. So that is very, very encouraging. And hopefully there will be something else that expands this implementations even more. And that is something called Jakarta EE core profile. We'll talk about that in a moment. That is definitely happening in Jakarta E10. And with that, what will happen is things like Quarkus will actually become Jakarta EE implementations as well. So this will be really an explosion of implementations. This is an intended effect, what we wanted to have happen. But certainly all of the traditional application servers, the ones that you would suspect when you think of Java EE, Jakarta EE, all of those are, in fact, at least Jakarta E8, in some cases, Jakarta E9 and 9.1 compatible also. Okay, so let me stop there, because as I said, I have been talking for a little while. Next, we're going to move into the Jakarta E10 end of things. But before I do that, let me stop and see if there's any questions that I should answer. What do you think, Roberto? Any questions so far?
Not yet.
Okay, let's keep moving forward. So Jakarta E10, the easy thing about the prior Jakarta EE versions and the easy thing about a small set of people controlling things is that they have the ability to essentially sort of publish traditional product roadmaps, right? Because at the end of the day, something is owned by a set of architects and a set of program managers or product managers. That's no longer the case. So the roadmap for Jakarta E10 will have to be a lot more organic in nature, right, rather than top-down in nature. So it will be bottom-up in nature. So in the Jakarta EE Ambassadors, which is a group that we formed some time ago, it was called Java EE Guardians. And actually, we played a role, I would say a fairly important role in moving, in actually happening, making the Jakarta EE transition happen and making that a reality, and sort of highlight the fact that there is a problem in terms of single vendor control. So we observed this problem actually close to a year ago now, right? It's like, okay, so somebody needs to drive the Jakarta E10 agenda. It's not going to happen on its own. So what we did was we actually got together as a group and said, okay, we've been in this technology space for a while now. We ought to be able to come up with some idea of how Jakarta E10 should look like. And also, the main objective of doing this is to give people an idea of where they should be contributing, or what are the kind of things that could be implemented as part of Jakarta E10. So we vetted this with some of the vendors, at least to some extent, and we have put together essentially a guide to contributing to Jakarta E10. In fact, the rest of the material that I'll be presenting for you in the next half hour or so, that is nothing much more than a reiteration of what is in the Jakarta E10 contribution guide. Okay, so you should definitely take a look at the contribution guide. I'm giving you the Cliff's Notes version in the next half hour or so. All right, so when you lay out all the features, there are definitely themes that emerge for Jakarta E10. One of the clear themes is CDI alignment. So definitely, frankly speaking, more directly speaking, this is about getting rid of EJB as a programming model. So this is, ever since CDI was introduced, we've had these competing programming models that look very similar, and CDI being a much more powerful programming model and a more modern programming model compared to EJB. So one of the things that needs to happen in Jakarta E10 or shortly afterward is moving all of these valuable features that are in EJB and moving them to their respective specifications and making them CDI based as opposed to EJB based. So some examples of this is at asynchronous, schedule, lock, max concurrency, message listener. These are all locked into the EJB programming model, either very explicitly or sort of implicitly. Same thing was roles allowed and run as in the security API. These are still, unfortunately, bound to the EJB programming model. So they could be unlocked from there and be made available to all of the CDI programming model, CDI programming components. Okay, so that is a big arc of work that still remains in Jakarta EE for sure. There's also some specifications that can take better advantage of CDI as well. So some examples of these are REST, batch, and concurrency. Okay, so they have these little bits of alignment problems where they can provide better support for CDI, but don't really currently.
Hey, Reza.
Yeah.
Yeah. Sorry to interrupt, because I think we have like a question that lines up with what you're explaining right now.
Sure.
So Carlos is also thanking for the talk so far, but he's asking, So an EJB versus CDI, should we move our applications to CDI-based component, or is there still future for EJB?
You can't right now. So if you're writing an enterprise application, there are several things that come up that are common enough use cases such that EJB still is necessary. So pooling is one, handling concurrency is another. Even things like declarative scheduling, asynchronous processing, message-driven beans, these do not have EJB equivalents today, right? So you can go a long way, and I would say by default you should favor EJB, favor CDI if you can. But there are some cases where functionality, if you want to continue to stick to the standard, really is locked into EJB. So there's no getting away from EJB right at this moment. You should favor CDI, but also make sensible use of EJB where you should, right? Where the features really does make sense. So moving on to the next major theme, Java SE alignment, as I talked about, there's definitely features that remain in Java SE that make sense for Java EE APIs to adopt. So some examples of that is bringing in completable features in concurrency. Concurrency today is based on Java util feature, not completable feature. So this is something that makes sense. Making more of these APIs standalone, right? So Java, as early as Java J2EE 1.4, there was an effort to make each of these technologies standalone. So it's not just part of a monolithic platform, but modular technologies that are available standalone. But there's a few of these that actually still can be decoupled further, right, and be made available as standalone technologies. And I think this is actually empowers the platform by expanding its use, right, throughout the ecosystem. There are some definitive cases where we need Java SE Bootstrap APIs. So currently the Bootstrap is only possible in a Java EE environment. So examples of that would be Jakarta REST and Messaging. So this has been done, for example, for CDI, but not for Jakarta REST and Messaging. So this is another thing that could be taken care of. And there are various standardization gaps, things that you do in a vendor-specific way, or things that you do 70, 80%, 90% of the time as a Jakarta EE developer, but these are somehow not standard. They're available in other APIs or in proprietary APIs. So these are things that I'll talk about in a little bit more detail as we go along towards the, if you will, the middle of the presentation. But another important thing that is happening in the Jakarta EE timeframe is the core or microservices profile. So this has also been a long time pending, and I've been a proponent of this since Java EE 6. So I'm happy that is actually happening now. And that is defining a very minimal part of the platform. So this is basically be something like CDI, REST, JSON binding, and that's it, right? Just what you would need to create a very simplistic microservice. That becoming a profile, and products that implements just those specifications, becoming full-scale, fully fledged, proper Jakarta EE compatible products. So things like Quarkus and Helidon. That obviously I think is going to happen very soon, sooner rather than later, probably in the next few months. And there are some cases for new specifications to make it into the standard as well. So I'll talk about a few examples of those that I think are definitely going to happen at this point. This is not just mere speculation. And that would be Jakarta Nosql, Jakarta MVC, as well as Jakarta Configuration. Okay. Moving forward, and again, feel free to post questions. Interrupting me is perfectly fine. And so we'll have sort of a more extended Q&A rather than a narrow one at the end of the session. Okay, so let's talk about Jakarta Concurrency. I don't have a lot of time. I actually have another talk dedicated just to Jakarta EE 10. This is a bit more of a broader talk. So I took about 20 minutes to give you an introduction, including 9 and 9.0. So the pattern that I'll follow now is that I'll talk about, in general, for a given specification, what are the probabilities? What are the things that could possibly happen that you could help contribute to? And I'll provide one code example of that. Okay, so if you go look at my speaker deck, you'll also see a deck dedicated to Jakarta EE 10, and that will have more expanded code examples at least. Okay, so let's talk about Jakarta Concurrency. Jakarta Concurrency actually is a very good candidate for moving a lot of very valuable features from EJB, because those features in EJB were actually intended for concurrency handling. Okay, so these are things like the @asynchronous annotation, the scheduling annotation, the locking annotation, defining the concept of maximum concurrency for a given simple component, defining the concept of perhaps pooling that I haven't put in this deck yet, but pooling turns out to be an important way of managing both memory utilization as well as GC, minimizing GC as well as performance. So those are some possible features that could go into Jakarta Concurrency. In fact, they've all been discussed and they're on the way to being implemented. So if you're interested in implementing any of these, you should hop onto the Jakarta Concurrency alias and begin contributing there. These other features have also been discussed, and I think they will happen as well. So right now, you cannot define a managed executor service in a standard way. So you have to do it in some vendor proprietary way, like a vendor XML. So it absolutely makes sense, just like we can define data sources and JMS resources today, to be able to define concurrency resources in a declarative way, either in XML or in annotations, as well as adding support for completable feature. So completable feature, if you use it, it actually under the hood uses Java SE thread rules. Okay, so that's not what you want in a Java EE environment. So the idea here is to create a version of completable feature that will enable you to use the app server's thread pool as opposed to the Java SE thread pool. CDI context propagation is another one. So when you create a new thread using the Jakarta concurrency model, it propagates things like security, transactions, your user context, so on. But the only thing it doesn't propagate is a CDI context, right? So this is an easy mix and an easy miss and an easy thing to fix also. And again, that is being fixed as part of Jakarta concurrency in its next revision. Here's a simple example of how I believe you could actually merge asynchronous and completable feature. So you could have a programming model that looks something like this. So if you want just something simple asynchronous functionality, you ought to be able to just annotate it with the @asynchronous annotation, any CDI component. And your programming model should look something like this, right? Where you return a completable feature, and all you do in your code is you write it as though it is synchronous code, okay, on your side, and do whatever you need to do except for calling completable feature dot completed feature and returning that object. But what the runtime can do is through runtime manipulation, actually turn this turn this method call into something asynchronous. Okay, so that the invocation happens asynchronously. You're able to process the method in a synchronous fashion, but the consumer can consume this method invocation in an asynchronous way. Okay, so basically they'll call process payment and then immediately get a completable feature back. Okay, that is a placeholder that is sent back by the runtime, and then you can call then accept to actually when there is a proper completable feature propagated from the producer side, you finally get a callback. This is very similar to how asynchronous works today in EJB, except that it returns feature as opposed to completable feature. Okay, Jakarta Messaging. I was actually part of a very interesting call on Jakarta Messaging. So Jakarta Messaging is one of those APIs that actually needs an overhaul also. So some of the possibilities here is a CDI-based modernized equivalent of MDB that would add more syntactic sugar and be simpler to use. So something like the add message listener interface. Again, messaging is one of those APIs you can actually create a standalone JMS implementation, but you cannot actually bootstrap it in a standard way without using things like JNDI. Okay, so there's definitely a space for creating a bootstrap API on its own for messaging. And also, as you know, Kafka and the modern, more modern cloud-centric ways of doing messaging, those are not quite the same as JMS. So JMS cares about things like acknowledgement, transactions, message ordering, message durability. Whereas these newer systems actually don't care about those concerns. They give up those concerns in the name of performance and scalability. Okay, so there is a case to be made of creating a lighter version of Jakarta Messaging that basically removes some of the requirements for providers and allows something like Kafka to more or less implement the Jakarta Messaging API because there's not as many features to implement. Another thing that has been there for a little while, and I think is doable, so things like RabbitMQ, right, do this. Azure Service Bus does this as well. So they implement AMQP as a wire protocol. Okay, so not as an API, but a way that the client and the producer should interact with each other or talk to each other using AMQP. So here's a message listener example. I won't go too much into it. So this basically looks like MDB. Couple of differences though. This is a CDI component, and notice that the syntax is a lot more compact. So you're not using all these activation properties. And you can also do more powerful things, like, for example, bake in things like retries and dead letter queues, and even batch processing. Okay, so receiving messages in batches. If you go into in a more modern syntax for receiving messages, as opposed to the old one that is there in message methods. Jakarta Security, I think it's actually in pretty decent shape the way it is, right? So we added things like providers for databases and LDAP. But there are some things that could be modernized and some things that could be added. Obvious one is making it possible to use roles allowed and run as in all CDI components and not just HAB components. And also adding some more modern security providers, so things like OAuth, OpenID Connect, and JWT. Again, a lot of this actually has been discussed already, and more or less there's agreement, right? And this is basically how Jakarta Security actually really looks like right at this moment based on consensus. So again, if you're interested in any of these features, you can hop on to Jakarta EE Security Alias and make these things actually happen. Okay. Here's some examples of how the modern security providers could look like. Again, there would just be a set of simple annotations, that under the hood, the provider would do a bunch of work for you to create these identity stores for you behind the scenes. So examples for OpenID, JWT, or OAuth 2. Okay, these are some things that could look like. Actually, these examples I pulled out directly from OpenLiberty. OpenLiberty supports all these features just in proprietary ways. The syntax is even almost exactly the same. Same thing for Payara. Payara provides some of these features, again, in a Payara-specific way. So very, very possible and very, very easy to implement these features in the standard, I think. Okay. Here are some other possibilities. So this is where we can talk about sort of closing the standardization gaps, if you will. I think the persistent.xml can be optional, specifically if you replace it with Jakarta configuration. It's very possible to make Jakarta persistence an optional artifact. In general, JPQL is pretty good, but it is missing some SQL features here and there. The most important one being the ability for doing subselects. So I think this makes sense for Jakarta persistence. Using JCache as a second level provider. So currently JPA has a concept of a second level provider, but it's JPA's own. So as opposed to doing that, you could simply use a JCache provider as your second level provider very easily also. Jakarta REST we talked about. So Jakarta REST today uses something called @context as an annotation, and it's really very similar to @inject. There's no reason not to simply replace that with CDI and deprecate the older features. Again, Jakarta REST could take example, could make use of a standalone Bootstrap API. This would be very helpful, specifically for testing environments, okay, where you just want to test something and you want to spin up maybe a small JAX-RS endpoint, and that's all. It's also useful in standalone applications or outside of Java EE environments. Native support for multi-part form data. I think this is a very easy one. It's been a gap for a little while. So this is a data type that isn't supported by JAX-RS implementations out of the box. Things like OpenLiberty have added support for this though. So this makes sense to standardize. Jakarta Batch has some gaps here and there. So CDI alignment, a lot of the things can be more injectable than they are today. Today, the job definition API is XML only. I think that could be Java-centric and CDI-centric as well. Jakarta transactions, when people think about Jakarta transactions, what they have in mind is actually something that's close to 15 years old. That is absolutely not the case in practice. So if you look at OpenLiberty or you look at WebLogic, they actually have a significantly different take on, in terms of its implementation, on how they can implement Jakarta transactions. So they have a lot of optimizations, like last resource commit, for example, or emulating two-phase commit, that I think could be standardized in Jakarta transactions. Instead of simply pretending that it's a two-phase commit only, we can accept the reality that it's actually not. Right? In practice, the implementations don't stick to strictly two-phase commit, and they have not been for many years. Okay. So here's an example of the job definition API. This is basically just a copy and paste of what's in JBeret, which is the Red Hat or JBoss Wildfly implementation of the batch processing API in Java EE. Okay, let's now talk about. Actually, let me stop for a second. So we have about 10 more minutes to go. This is just about right timing. Before I start talking about some of the newer APIs that could make it into Jakarta E10, let me stop and make sure there's no questions. Okay, I take it there's no questions. So let's move forward. So Jakarta MVC is an important one. This basically allows you to have an alternative to JSF. I love JSF, don't get me wrong. If somebody told me, hey, pick your web framework, I'd say JSF any day. It's very compact, it's very Java-centric, and it's very, very abstract. So you don't have to deal with the low-level details of HTML, get, post, and all of these things. However, there is a class of applications and a class of developers that don't like that level of abstraction. They want something a lot more like old school struts, where you are really dealing with the lower level details of HTTP syntax. And what this also allows you to do is that it allows you to put in more JavaScript in there. JavaScript is a little bit difficult to process in JSF because of the fact that it does a lot of things under the hood with the HTTP request itself. So this could be very, very simple. And in fact, it has been out there for a little while. So you can, as a model, you can use CDI and bean validation. As a view, you can use facelets or Jakarta service spaces or AKA JSP. But most of the work is actually in the controller and defining the Jakarta REST. So this can be a very lightweight specification. In fact, it is. So this used to be part of the JCP. It is now actually a Jakarta project. I think it's very likely it's going to make it into the platform in some shape or form or the other. So here's an example of it without going into greater details of it. So you would be defining a controller. You would be essentially very low level handling of HTTP GET and so on. And all you would do in terms of rendering is either send the model back that should be rendered or create a model object and put your values there as name value pairs. Jakarta Nosql, this could be a talk on its own, but this is an attempt at basically standardizing Nosql databases for Jakarta. Okay, so this again already exists. This used to be JNoSQL. Then it was moved to a standard Jakarta Nosql. It's still not final yet. It'll be final soon. But it's fairly feature complete. I definitely encourage you to take a look at it. So the basic idea behind Jakarta Nosql is to have different levels of abstraction geared towards specific use cases. So there's a communication API similar to JDBC. There's a mapping or template API similar to JPA and entity managers. And there's also a repository API more similar to Delta Spike or Spring Data. Okay, so there's all these different layers of abstractions. It supports a very large set of NoSQL databases already. I think there's almost 50 NoSQL databases supported by the JNoSQL implementation. And it does have a notion of a taxonomy. Right? So it recognizes the fact that there's different types of NoSQL databases, namely key value pair, column family, document, and graph. And there's also other tie-ins into Java EE as well. So it supports integration with bean validation as well as micro-profile configuration for now, probably Jakarta configuration in the future. So here's a simple example. Looks a lot like JPA, but a little bit of more taxonomy-specific syntax. So familiar things like entity, ID, column, bean validation integration. But if you look at the entity manager API, that looks very different. Okay, so that is specific to the domain or the type of underlying database that is supported. Okay. Configuration is a big one. Okay, so we've been talking about this, believe it or not, since Java EE 6 as well. And for some reason, it just didn't happen in the Java EE timeframe, sadly. So what this is about is about externalizing configuration, or expanding the notion of configuration aside from just having XML and annotations. So the most obvious example of this is just property files. Okay, so there has been attempts to address this gap for a little while. So there's Apache Tamaya, and also there's a configuration module in Delta Spike and so on, right? So this actually has been around for a little while, and it's definitely manifested in a fairly complete fashion in microprofile configuration. So the objective here, the problem here is that without creating a circular dependency, it's not possible to refer to Jakarta configuration inside of Jakarta EE specifically, because microprofile already references Jakarta EE APIs, right? So what you actually need is you need a sort of a clean room copy of something like microprofile configuration in Jakarta, and in fact, this is already happening. So there will be built-in stores of property files, Java system properties, environment variables, but then you ought to be also be able to easily extend it. And in fact, there could be a plugin ecosystem of things that extend the notion of configuration, or where configuration comes from. So this could be, it would come from Kubernetes secrets, Kubernetes configuration maps, perhaps secure cloud storage. So we have something called Azure Key Vault in Azure. In my day job, the configuration values could be coming from there. It could be coming from various NoSQL stores like MongoDB and so on. The primary use cases are, in terms of the API, is being able to inject these configuration values, being able to reference these configuration values in XML. So referencing, for example, environment variables inside of XML, and also all of this can and should be done through microprofile alignment. And I think this is the way things are going to go. In fact, there is a proposal out there to make this happen. And I do hope that it will happen through microprofile configuration instead of a wholesale yet another reinvention of the same thing. So we've already had plenty of reinventions of this, as I talked about. First, it was Apache Tamaya, Delta Spike configuration, then microprofile, then the JCP configuration specification, then Jakarta then microprofile configuration, and I hope it's finally going to settle down in Jakarta configuration in a more stable way. Okay, so here's a couple of examples of what I was talking about: injecting values into fields, being able to define it in property files. For example, in this case, I'm referencing to basically making the persistence XML file optional, as well as being able to reference these configuration properties inside of existing XML deployment descriptors, like the web XML, for example. Okay. So finally, let me stop with excuse me. How do you contribute? So these are the different ways that you can contribute. The first way you can actually contribute is just by delivering this talk. If not that, you could join these mailing lists and track their progress and chime in as an end user, provide perspective on how you would like an API to look like. What are your priorities? You can advocate for a specific change. There's a change that you would like to see happen. You can join a particular Jakarta EE project, and you'll see a list of projects in the link that I provided, and say, hey, this is a really important feature. This is how I would like to make it happen. Okay, so one is an observer role and participant role. The other one is driving the change. You can help implement a change in the specification. Believe it or not, a lot of these things that I talked about is surprisingly easy to implement. Okay, so you could actually be implementing these changes yourself, and it's very easy to do. You just need to sign the Eclipse contribution agreement, and that's about it. You can begin contributing that way. There's more paperwork, but it does not come in until you want to be a committer. Okay, and that's farther down the line. And of course, if you have questions on any of this, or just want help to get started, or just want to talk to someone, you can always depend on the Jakarta EE ambassadors to help you. So that you can log on into the website, figure out how you connect with us, and then have us help you, help the specification. All right. So in summary, I'm almost out of time now. In summary, 8, 9, 9.1, very significant features. You should definitely take a look at them if you have not done so and begin testing them out and adopting them. They're good, solid bits of technology. Important changes coming in Jakarta EE 10 and beyond. You can also, at least in the interim, take a look at microprofile also. Okay, some of these features that we talked about are in microprofile. So if you combine 9.1 or 9.0 or 8.0 with microprofile, you have even a more powerful technology combination. I'd say probably the most powerful technology combination you can have, especially if you're using a runtime like OpenLiberty or Quarkus. But the main thing that I really hope you will consider and take away from this talk is none of this will happen without your participation and without your contribution, right? And remember, this is one of the key reasons why we did the move. So it shouldn't be all about vendors and people that get paid in their day jobs doing this work. It can also be people like you, okay, contributing to making a real contribution to moving these specifications forward. We made it as easy as possible for you to do that. So it's really up to you. So here's some resources that I'll finish with. Jakarta One is a very good conference on all things Jakarta and microprofile. You can log on to the Jakarta One website, and there's a ton of recordings on various Jakarta topics, including some of the things that I talked about today. In fact, they may even have my Jakarta EE 10. In fact, I know they have in the last Jakarta One, they recorded my Jakarta EE 10 talk specifically. So you can take a look at that also as a recording form, as opposed to slide deck form. If there's one alias that you join, please join the Jakarta EE community alias. This is sort of the announcement alias, the highest level alias in the Jakarta EE community realm. So please join that mailing list if you're not going to join anything else. You should definitely follow the Jakarta EE Twitter handle. I know all of us are on Twitter, right? Please don't tell me otherwise. So please follow the Jakarta EE Twitter handle. Hopefully you get to, you also follow the Jakarta EE ambassadors. We provide more information than the Jakarta EE official handle typically does. And also there's monthly talks on Jakarta, okay? You can join those talks. It's an incredible resource. And I think very few technologies have like a technology specific talk series is like that on a monthly basis, but Jakarta does. And that's called Jakarta Tech Talks. In fact, I just did a Jakarta Tech Talk
Hey, Reza.
some of my colleagues in IBM just yesterday. Yes.
Yeah, sorry, but we're really out of time. I gave you like a couple of extra minutes. I'm really sorry to have to cut you down now like this, but really have to go to the breaks because we have some videos to post and prepare the next speaker. Anyway, thank you so much for the great presentation. There were a couple of questions that I'll probably try to put you on Twitter, and hopefully we'll see each other again really soon.
Yeah, sure thing. And I'll post the slide deck on the chat for people too.
Okay, wonderful. Thank you very much.